Done. So, morning, I was telling you about instance variable, the local variable, and about our objects. So, lastly, we covered this example. So, I was telling you how we are going to be creating multiple objects, how each and every object is going to be having its own copy of the instance variable, and how to give individual values for each and every object. So, these were the concepts that we were seeing in the morning. Okay, now let us say, for example, continue with the same example what we have here. So totally three objects have been created. So now my thing is I have to give the value for all the three objects, and everything has to be dynamic inputs. All the three has to be a dynamic input. So how to go about it? Please understand what I'm saying. What I am telling you is there are three different objects. Okay, all the three objects needs to be initialized with dynamic inputs. So this is for one object. This is for the first object. Now, if I want to give the second object also the same type of values, the third object also the same type of values, what am I supposed to do? I have to repeat this set of statements. Am I right? So what I have to do? I have to copy this out. Then for the second object, I have to give the values like this. So this is for T2. Now for the third object, so this is for T3. So T3 is roll number, T3 is name, and T3 is average. So you see here. Now imagine if I am having 30 objects as I told you in the morning. But 30 times this line of code needs to be repeated. And imagine here I have only three properties. Only three instance variables are there. What if I have more? I have email ID, I have gender, I have age, I have mobile numbers. So like that, I have many instance variable. I want to get the value for all the instance variable dynamically. I'm having 30 objects of my class. Imagine how many times the same code has to be repeated for each and every object. So here we see what is the difference here. This is for T1. This is for T2. This is for T3. So for each and every object, the same line of code is being repeated. So only difference is while storing it, the object name is different. So now this is what we call as a redundancy of data. Data redundancy. So data redundancy means repetition. Data redundancy means repeated things. Repeated codes. Repeated codes again and again appearing in my program. That is same task. You are meticulously doing some 10 times, 15 times, 20 times. Imagine how many lines of code is getting wasted. And because of this data redundancy, what is happening? Program size is becoming larger. Program size increases. Imagine this is some 6 lines of code. 6 lines of code I am repeating 3 times, one for each object. So imagine the number of lines that is getting repeated. Imagine the same scenario for 30 objects. 6 into 30. That much of redundant line will be there in my program. So that is another problem that I am going to be facing. One is obviously data redundancy. Second one is because of this data redundancy, my program size is getting increased and program readability becomes a problem. Readability of the program is getting spoiled. And I see the same line of code again and again. What is this here? That's what I feel like. Same thing for, see, same thing for printing also. So same lines of code, only thing is object name is different. So again, redundant data. How can I avoid this redundant data? That is the question. See, a programmer always should write neat, readable, and efficient codes. It should not be like this. So how can I avoid this redundancy? There is the concept of your functions. All these are the problems that I am facing in a program. So problems while writing the code. So these are the problems that I'm going to face while writing the code. How can I avoid? Or what is the solution for all these above mentioned problems? The solution is methods. Using methods. Using methods, or what we also call as, it is also known as functions. Also known as functions. So this is the solution that is offered for this program. So when I make use of methods, what is the advantage I get? What is the advantage I'm going to get? Advantage number one, most important advantage of all, reusability. Reusability. That is, write the logic once and call the function, or call the method whenever that logic needs to be executed. So please understand what it is. Reusability means write the logic and keep it once. So wherever I want, use the same logic, call the same methods. That's all. So reusability. Second advantage is, because of this reusability, redundancy is avoided. Data redundancy is avoided. And because of data redundancy is avoided. See, each and every advantage is always interlinked with each other. Since data redundancy is avoided, program size decreases. Program size decreases. Because my program size decreases, readability of the program increases. So readability means when I look at the program, I should be able to understand how the flow of the program is going in a easier manner without any confusions. Now, out of all this, one more advantage is there. What is that? Easier for debugging. Easier for debugging. Debugging means finding and fixing the errors in the program. All these are the advantages when I make use of the concept of methods or a function. So normally when I write a program, these are some of the problems that I will be facing in my program. So how can I avoid this problem is to make use of the concept of methods. So when I make use of these methods, these are the advantages that I am going to be getting for that. Right. Understood? Right. So now, so what exactly is the function and how to define a function? Guys, sorry, just give me 1 minute. Yeah, guys, I'm sorry. So yes, as I was telling you, methods. So what exactly is a method or a function? A method or a function is nothing but set of statements that are, or let us call it a set of instructions to perform a specific task. Nothing but, what is a method? A method is nothing but a set of instructions that is used to perform a specific task. Okay, again, I haven't had that. So, a set of instructions to perform a specific task which is returned within a named block. Now, what do you mean by return within a named block? Whenever I create a function, I give a name for that function. So that is the reason I'm saying it is specific task. It is used to perform some task and it is given within a named block. Syntax. How to create a function? First, we have to specify the access specifier. Access specifier followed by the return type. Followed by the return type. Then your function name or the method name. A method is always represented by this parenthesis or this parameters. Okay, by this parenthesis, inside this parenthesis, you are going to mention your parameters. Okay, this is the function syntax. So how you write your function? Access specifier followed by the return type, followed by the method name or the function name. Okay, then within the brackets, you are going to mention the parameters. Then you will start the block. Then you're going to be starting the block. So inside the block, you're going to write the code statements. Like, what is the purpose of creating this function? I told you it is created to do some specific task. What is the task? That code you are going to write inside of this block. So whenever we are going to create a function, that is why I said it is a set of instructions that is placed within a named block. Right. So this is the general syntax of a function or a method. Now, what you have to remember is whenever I talk about methods, okay, we can categorize the methods into two types. The first type is what we call as a built-in functions. Built-in functions or built-in methods, which is nothing but my predefined, methods. Predefined methods. Like, for example, println. Println is a function. Remember, we always use that parenthesis for the print. You have all the scanner class methods. Next, you have next int. You have next to double, next to float. Like, there's so many functions are there. Am I right? The list just keeps on going. So many functions are available for us. All these functions are built-in functions or what we call as predefined. It comes along with the programming language. It comes along with the programming language itself. So you are not creating it. The second type of function what we have is what we call as a user-defined functions. User-defined functions or the user-defined method. These are programmer defined, programmer created functions. So, according to your project's requirement, you are going to decide, okay, this is my requirement or this is my program. So, for this, what are the functions I require? According to the project's requirement, the programmer or the coder, they are going to create the functions. So, creates these methods. That is what we call as a user defined methods. Right. So basically, whenever I talk about a method, methods are classified into two categories. One is built-in, that comes along with the programming language. Another one is user-defined, that is created according to my program's requirement. Now, our focus is going to be on the user-defined methods only, because you are going to create functions in the program. So, user-defined functions are categorized into two sections. So, any function created by the user or by the programmer is classified into two sections. What are those sections? Method, definition, and method calling. So, these are the two sections that is present for each and every method created. So, please remember, every method that you're creating, that is created, consists of two sections. What are they? One is called as method definition and the other is called as method calling. So these are the two sections that is available for a function or for a method. Right. Now, this is the syntax of method definition. Please remember, this is a syntax of my method definition. Now, what is this method definition? Method definition is writing the code of the function. You're going to create the method. For what purpose you're going to create? To execute something. To execute what? That is what you're going to write in method definition. Writing the code. Purpose of creating the function. Writing the code means what? Purpose of creating the function. What is the purpose of creating that method? That is what you're going to mention in the method definition. So, access specifiers. So, now first thing what you're writing? Access specifier. Now, what is this access specifier? You have already seen access specifier while writing our variables also. While creating our variables also, you remember the syntax what I told you. It starts with access specifiers. See, syntax is it starts with access specifier. Right. So what are all these access specifiers? So when I talk about local variables also, it is possible for me to give an access specifier for them also. So what exactly is this? So access specifiers in Java is of four types. So what is the purpose of this? It is used to control. It is a control mechanism. It is a control mechanism. That is, who can make use of my method? It exactly defines who can access. So control mechanism means what it is going to take care of? Accessibility. It is going to be taking care of accessibility. Who can call my function? Who can make use of my function? Now you may ask, we are creating the function. Who is going to call my function? So please imagine you are working in a project. Project is not handled by a single person. Project is handled as a group. So there will be multiple people working on the same project. So a class which you are developing, maybe another person working in the same project may require that class, may require the function that you are writing. So it has to be shareable. So you have to decide, can they access? Is it, am I going to create a shareable function or not? So that accessibility control you can specify with the help of this access specifiers. So the four types of access specifiers what you have here in Java. One is public, private, protected, and default. So these are the four types of access specifiers that we are having. Okay, these are the four types of access specifiers or the control mechanism we have in Java. Please remember, this is also a way of enforcing the concept of encapsulation. So remember our oops, encapsulation, data hiding. How do I hide the data? By preventing the access to it. So it is also a way of enforcing the concept of encapsulation. So now here, first, let us start with this default. Default is an access specifier that is added by the compiler when the programmer does not explicitly mention any access specifiers. Please remember this very carefully. Default is an access specifier that is added by the compiler. Programmer cannot add default. Okay, as a programmer, you cannot create default int m1. No. Default is a access specifier that is only added by my compiler. So when is my compiler going to add the default? When the programmer does not specify any access specifiers. For example, you are creating a function like this. Okay, you are going to create a function like this. I am saying void m1. This is the name of my function. Inside that, I'm just saying, okay, int a is equal to some value. Int b is equal to give some value. Then I'm saying int sum is equal to a plus b. Then let us just say system dot out dot println of sum. This is the code I'm writing. So this is a function. The name of the function I'm giving as m1. Okay, so inside this function, what is the purpose? This function I have created to add the two numbers. Okay, simple function. Just to explain you the thing, I'm doing this. Now, have I mentioned any access specifier here? Look at the syntax. Access specifier, return type, method name. I have not mentioned access specifier. Method, return type is there, method name is there. So when you are not mentioning any access specifier, then for this, compiler will automatically add default. So compiler here is automatically going to add default as the access specifier. So this is how my default is working. Okay, so this is how my default will be working. Now, the second access specifier, what I am going to be discussing is our public. So public access specifier is the Least secure. Least secured. That means what? Zero security. Least secured means zero security. Anybody can access. Anybody can access. Can access the variables and methods. So variables and methods that are declared as public. So what it says? Least means it has zero security. Anybody, in the sense, any person, any class. So a project consists of 10 classes, 11 classes, 12 classes. So all class, okay, whichever you have created can access the public and the public variables and methods. So that is what I mean, zero security. Like that is what we call now public properties. So anybody can access. It does not belong to any one particular person. It's a common, shareable. That is what my public is. The next is what I have is private. Private. So private is the most secured. Or what we say is the highest security. Highest security level. Highest security level is given by the private. So whenever you declare a variable or a method as private, so it can be accessed. It can be accessed only by the class in which it is created. It can be accessed only by the class. That is only inside the class in which you are creating that variables and functions. Say for example, I am working in a project. So in my class, I am creating my variables as a private variables. I am creating my methods as a private method. That means only I can make use of those variables and methods. There will be one of my colleague working on the same project. He will try to access my method. It will throw error. Why? It will say, sorry, they have created it as private. So you cannot access it. So private properties. It belongs only to the class in which you're creating it. It does not belong to anyone else. Zero shareability. No one can share the data. That is what we mean by private. Now, the third level of security, what I have is protected. Protected. So, protected is kind of like the second level. Second level, next to private. Next to private, I can say, okay, protected. So, what is this protected? Protected will allow the current class and its subclasses to access the variables and methods. So current class can access subclasses. Subclasses means what? When I am creating a parent-child relationship, inheritance. So I am the parent class. I am having protected variables, protected function. So who can make use of that? My child can use it. So my child class can make use of it. No one else but my child class. So that is what you mean by protected. So the current class means in which you're creating it and its subclasses. Okay, and its subclasses in the sense nothing but child class. Child class can access the variables and methods. So we will discuss more in detail about the access specifiers. Okay, this is a very, very important topic. We will be specifically discussing programs based on this. Here, I am just giving you guys an introduction. Right. Okay. Now, so that is my first word what I'm going to use. Now, coming to the second word, return type. Now, what is this return type? What is this return type going to do with functions? That is the next question. So please remember, return type is nothing but the data type of a method. Return types are nothing but the data type of the method or data type of the function. Now, I told you the function is created to do a task. So what is the purpose of creating the function? To do some task. So after doing the task, I am going to be getting a result. Right or wrong? After completion. So after the completion of the task, we are going to be getting the result. My question is, what to do with the result? What to do with the result? This is what your return type decides. So what is a return type of a function is, a return type decides what needs to be done with the result that is achieved after executing the function. Once the function is done, I am going to be getting something. What am I supposed to do with it? The function can handle it in two ways. One, it can print the result. I can do this, right? Inside the function, I'm doing some calculation. Then I myself can print the result. For example, here, take this code. Take this code for example. What are we doing in this code? In this function or in this method, what is happening? We are adding addition of two numbers. That is what is done by this method. But after calculating a plus b, I am getting a sum. The sum is nothing but my result. What am I going to do with that result? So here in this case, the function itself is printing the result. The function itself is printing the result. In such scenarios, the return type or the data type of the method is void. Data type or the return type of the method is void. Void means nothing. Void means nothing. That is, the method does not return any value. The method does not return. It does not give back anything. See, you are giving it a work. It is doing the work. That's all. It is not going to give you any acknowledgement. See, I have done the work. This is the result. Like that, it is not going to be giving you any acknowledgement. That is what we are calling it as void. Void means nothing. So this function, how I am going to create? I am going to create as public void addition. This is how I am going to be creating this function. So this method is to add two numbers, and after adding, the result is printed by the function itself. So the function itself is handling the result also. So in such scenarios, I will be giving the return type as void. So please understand, when you should use the void keyword as the return type is whenever your function is not going to return anything, when it is not going to give back anything. That is what we call as your void. Right. Now, the next thing is, the function can also return something. What is it going to return? Nothing but the result. It is going to return the result. So it is going to have the data type of the result. Data type of the result is my return type of the function also. Please remember the two possibilities here. Okay, the function return type is two possibility. So possibility one is void. So you're going to say function is not going to return any value at all. Possibility two, the function is going to return something. Okay, what is it going to return? Whatever is the data type of the result, that is going to be the return type. That is going to be the return type of the method. Right. Now, let us try to understand this. Okay, so let us say I'm going to create a function. So for the second method, that is method returning some value. So same addition, let us take same addition. But what is it going to do? Add two numbers. After adding, the result is given back. The result is given back or sent back. Sent back to where it is going to send. Where it is going to send. Sent back to the place from where the method is called. It is going to be sent back to the location from where the method is going to be called from. Now, what is this method being called? What do you mean by the concept of method being called? So, I already told you one thing. I hope you remember. Any user defined function you're creating will consist of two sections. One is method definition, another one is method calling. So, syntax for your method calling. This is for your method calling. How will you call the method? You are going to mention the return type, or you're going to mention the method name and values for the parameters, ending with a semicolon. This is how you will be calling your method. Okay, now what is the purpose of method calling? Method calling is done to execute the code. Execute the code written within the function. So in the method definition, you are going to be giving some code. You are going to write some statements inside. So when you call this method only, these statements are going to get executed. If you don't call them, they will never get executed. Methods are just like us. Until somebody pushes us, okay, did you do this? Did you do that? Have you completed? Then only we will be doing that work. Otherwise, we will not do it. Same way our methods are. Unless and until the function is called, it will not do its task at all. So that is what you mean by method calling. Okay, so here what they say, method will do the calculation. After doing the calculation, it will get the result. So it is not going to print the result. It is not going to take up the responsibility of printing the results. See, what is the method going to say? See, my job is to do the calculation. I have done the calculation. This is the result. You keep it. You take it. You do whatever you want with it. That's it. So that is why I said the method returning some value. Okay, so it is going to give back the value. Okay, to whom it should going to give it? Whoever is calling the function. From where you are going to call that function to that location, the result is going to be given back. Simple concept here. You are placing some order. In Amazon, you have ordered. You don't like the product or the product is defective. So whom will you return? To the same person from where you ordered, right? You will not buy from one place and return to some other vendor. That is same thing here. The function is going to return the value to the person who has called it. Simple as that. Right. Now, how to handle this? How to create a function for this? Now, please remember, I will be making use of one keyword called as return. Whenever a function is going to be returning some value, I will be making use of this keyword return. This return keyword is like a delivery person, like my postman. What is the postman doing? Carrying the letter from one location and giving to it to the other. That is what this return also will do. It will carry the result. Whatever result you are asking, you're giving, it will carry the result and it will give it to the place from where you are calling the function. Please understand, the return is a keyword which is going to act like a courier or like a delivery. It is going to collect the result from the function and it is going to deliver it to the place from where you are going to call that function. That's it. That's it. Now, let us rewrite the same function. Let us rewrite the same function. I am going to do the same operation. I am going to add these two numbers. I am going to be getting the result, but I don't want to print this result. I just want to give it to the place from where I'm going to call this function. They will take care of the printing and all. Now, understand, this function is going to return a result. That is nothing but addition of these two numbers. So what is the data type of it going to be? Int. The result is going to be of the integer data type. Now, what did I say? What did I say here? Data type of the result is going to be the return type of the method also. So here my function is going to return an integer value, means the return type of the function also is an integer. Right, the return type of the function is also an integer because it is going to return the total. The total what data type? That is what my return type is. Now, who is going to carry this result? Return. So, return. Okay, what should I return? I should return this sum value. So, I will say return sum. That's it. Done. So, same function, you can either write it like this or you can write it like this. Which one to choose is 100% programmer's choice. It depends on the programmer. It depends on the program. How the program is asked. How the requirement is given. Based on that, you have to choose how to go about it. Clear, guys? Right. So this is the concept of my return type. So access specifier, then of course I have the return type. Now, the next thing what I have is my method name. Is my method name. Please remember, method name is an identifier. Again, method name is an identifier. So rules of an identifier, remember, enforce it. So make sure you're following all the rules that are there for an identifier. Then comes the concept of parameters. So parameters are a way of, it is a way of passing informations to a function. Now, we will discuss more about the parameters in our next example. First, let us see a simple example for this, for what we have understood so far. Right. Now, concept number one, what you have to understand is, I am going to be creating. Okay, I am going to be creating instance methods. creating instance method. I already told you instance. Instance is equal to object. So methods belonging to the object. Instance methods are methods belonging to the object. How to use it? How to use them? So for using them, you have to say object name dot method name. How did we use the variables? Same way. How did we use the variables? Same way you have to use it here also. Object name dot method. Anything that is instance means it belongs to the object. And whatever belongs to the object, this is how you're going to be calling it. This is how it is going to be called for. Now, let us rewrite this program. Let us rewrite this program. I am having too much of data redundancy here. I want to cut short all this. I want to make this a cleaner code. So I am going to create some functions. So what is the first function I'm going to create? See, you're going to create the function outside of the main. Don't create the function inside the main. Not allowed. So create it outside of the main. So what is the syntax? Access specifier. So I'm going to keep it as public. All right. I don't want any return type. This function is not going to return any value. So void. What is the purpose of this function is I am going to create this function to read the values of my variables, that is get data. So that is what I am going to call this function as. I am going to say get data or get information, any name. It is a function name. It is your choice. So this is my instance method. Instance method. Okay, done. So now what should be done inside this? Of course, I have to create a scanner class object and let me take this code and put it inside here, but no need to access t1 dot, t2 dot and all. You are simply going to say like this. I will tell you how it works. First, let us write the code, then I'll tell you how it is going to be working. Done. I created the object of the scanner class. I called all the inputs, stored it. Now, I want, now these data are not required. So take it out. Same way, I want something for printing. I want something for printing. So there you go. So I'm going to create another instance variable. Or sorry, instance method. This method is for printing. So public void show data. I'm going to call this as show data. Inside that, yes, there you go. I am saying int I is equal to 1. Or rather not needed. Now not needed. We'll go later. Okay, so there you go. Student information. Now again, remove all this. No need of T1 and all. Just the usual. There you go. So this is also not needed now. See how my code has become. I have one function. Inside that, I have the information to read the data. I have one function which is to display the data. Done. My work is done. So printing the instance variable. There you go. For the dynamic inputs. Obviously, I have minimized the number of lines. So now this is my main method. This is the code for my main method. Now I'm creating the objects. Yes. Now let me run this program. So instance variables are created, instance methods are created, my main function is there. Inside the main function, my objects are created. Everything is there. Now I'm running the program. See what happens. Are you seeing any output? Is the scanner class asking for any input? Enter name, enter roll number? Nothing. Why? There is no calling. This is what I said. What we have given here is just the function definition. This is nothing but the definition or method definition. This is just a method definition. You're just saying, see, this is the function. Purpose of this function is to execute these lines of code. But unless and until you call the function, okay, unless and until I'm going to call the function is never going to get executed. So you need function calling. So method calling. See what I'm going to do. T1 dot. What did I say? How to use it? Object name dot method name. So T1 dot. So first I am saying get data. Okay, so T1 dot get data. Then for the first object, I have got the data. Then I'm saying T2 dot. For the second object, again, I am saying get data. So now I have got the informations. I want to print the information. T1 dot show data. T2 dot show data. Remember, each and every object is an individual entity. With which object you are calling, that object's information is what is going to be get. That object's data is what is going to be displayed for us. So that is why here I am not using T1 dot roll number, T1 dot name. Why? Because with which object I am going to call that function, automatically the compiler will take care of it. When I call this get data with T1, so all these lines of code inside is going to get executed. Compiler will automatically add T1 dot roll number, T1 dot name, T1 dot average. When I'm going to call the same get data function, but with T2's object, again my compiler will automatically add T2 dot roll number, T2 dot name, T2 dot average. So I don't have to bother about that at all. All I need to do is whichever is my redundant data, put it inside a function. Then using the object, call the function. Now let us run this. See, first time what happens? Remember, a program's execution always starts from the main method. So first object will be created, then T1 dot get data will be called first. So whenever a method is called, what will happen? Control from this line will be going inside the function. One by one, it will execute all these lines of code. Once it is completed, it will come back here. Now this line is over. So it will go for the next line. So next line again get data. Once again the control will go inside the get data and it will create all this. For which? For T2. Right. So that is why first time it is asking me, okay, enter the roll number. So I am giving, okay, this is the roll number. Enter the name. Okay, name. Sorry, spelling mistake. Okay. So now enter the average. Done. See, once again it is asking enter roll number. This is for the second data. This is for the T2 object. For the average. Now look at the result. Object, variables, data belonging to T1, variables belonging to T2 object. So this is the usage of functions. No matter how many objects you are creating, I can reuse the same thing again and again. No need to write the code variable times, various times. Write it once. Whenever this piece of code needs to be executed, you are just going to call the function. Done. That's it. Simple result. Okay, simple way of creating a function and calling a function. So let me add this as an example in your document. So example for your instance method, how to create them and how to execute them. Right. So let me show you one more example here. Okay, let me show you one more example. Let me say I have double M1, M2, M3. Three subjects are also there. Three subjects are also there. So what I'm going to do is I am okay. So let us create here. I'm taking it for M1. Same way, let us do for M2 and for M3. Right. So three subject marks I'm taking. Now let us say M1, M2, M3. I'm just printing the three subject marks here. Now I'm going to be creating one more function. I'm going to create one more instance method. Now, what is this method going to do? See here, public double calculate AVG is the name of my function. Calculate AVG is the name of my function. Okay, what am I going to do inside this? Inside this, I am saying return, what should I return? M1 plus M2 plus M3. So this is what I'm going to be returning. I am saying, guys, 1 second, sorry. Yes. Sorry, guys. So calculate average. What am I doing? M1, M1, M2 plus M3 divided by 3. That is going to return my average. So what did I say? Whenever you are saying a return type. So here my return type is a double. Why is it a double? M1, M2 and M3 are my double variables. So obviously when I add and when I divide them, the result is also going to be of the double data type. So that is why I am creating this function as the return type as double. And this is the value it is going to give back. Where it is going to give? To the place where you are going to call the function. To the place where I'm going to call the function. Where I'm going to call the function? Inside my E1 dot calculate average. So inside the main function, I am going to be calling this. I am going to be calling this. So here the return keyword will bring this value and put it in this place. Now I already have a variable here. I am going to make use of that variable. See what I'm saying? E1 dot average is equal to E1 dot calculate average. So whatever this function is giving me, whatever this function is returning, that returned value, I am storing it inside this variable. So whatever this function is going to give me back, the returned value, I am storing inside this variable. And then my main function is taking care of the printing. And the main function is going to take care of this printing. So what it is going to do? Average is equal to E1 dot avg. So these two methods do not return any value. So you're simply going to call them. But this function, this method returns a double value, which is stored within the avg variable. So this is what we are going to be doing here. Now let us run this program and see whether it is working. So first I am calling the get data. Right. So yes. Now first subject, second subject, third subject. See what happens. Student information. Roll number 101. Name Geeta. What are the students' marks? 85, 90, 90. Oh, sorry. My mistake. Here I have used the same variable name, I guess. Yes. See here. And 3. Now, sorry. Let us run it again. Okay. Now see. 98, 85, 90. Perfect. What are the marks I have given? Then it says average is 91.0. So adding these three, the values are divided by 3 and that is what you are going to be getting. So a function which will return some value also, a function without returning any values also. So how to create the function is entirely your choice. Based on what your program, what your function is going to do, you will decide whether I need a return type or not. Whether a return type is required or not. See, the same thing can be written without this also. Let me call this as avg1. Okay, I'm going to call this as avg1. Here also, let us make that change. Let us create the same function, same working, but without the return type. No return type. I'm going to say void. I'm going to call this as avg2. So what I'm going to do here, I have that average variable already declared. So I am going to say AVG is equal to M1 plus M2 plus M3. Okay, add all these three values and then I'm going to divide it by 3. That's it. Then I'm printing the result also inside this. I'm printing the result also inside this. Average, or let us say students average is equal to plus AVG. Done. This is also correct. Here what is happening? We are calculating the average and we are passing that value to my main function. So the main function is handling it. Otherwise, you can also do the same. So here what I'm going to do, same way, T1 dot calculate average. Let me add a new line. Sorry. Now run this. See, roll number, name, okay, my marks. See, average calculated by this method and average calculated by this method, both are same. No difference. So as a programmer, I can write the function in this way also, in that way also. So this is the same average function. When it is returning some value, this is the same average function without returning the values. So you have to decide again and again. I'm telling you, there is no fixed rule. You have to create a function like this only. Like that, there is no fixed rule here. Only thing is why we are going for functions, so that I can reuse that code. I can reuse that code anywhere within the program. Wherever I want to calculate the average, I can just call this. Wherever I want to read the input, I'm just going to call this. That's it. So that is the basic idea between functions. So how to write the function, whether to keep the return type or not, all those things is you have to decide. You have to see which is the most suitable one for your program and you have to take it out like that. So guys, I'm just going to